So I'll go through the agenda, and if you feel like it's not a good talk for you, I won't be offended. Feel free to jump over to the other one. Want to make sure that always happens. And wave furiously at me if it's too echoey. So I'll go over who I am a little bit, talk about our usage at SmartThings of Ratpack and kind of what we have in production and what our experiences are. Then how to organize your app, when to use reusable handlers, and how to go about sharing a set of functionality. Then we'll kind of drift into monitoring Ratpack and then how to actually adapt libraries for use inside of Ratpack. And then I have a handful of things that didn't really fit in any other category that were all things that somehow hurt us in production that you should know. I will tweet all the slides out as soon as I have internet working, so do that next. So I'm Jeff Beck. You can follow me on Twitter at BeckJ01. You can reach out to me there. It's usually the best place to get a hold of me. I'm a software architect at SmartThings. We are an Internet of Things company. We are wholly owned by Samsung now. That's all I think I need to cover about that. We use Ratpack in production quite a bit. So we have currently 5 services in production with Ratpack, and there's 2 more being built out right now. And of those 5, they've been of the 5, 3 of them have been in production for more than 9 months. And so we've been with Ratpack since it went 1.0, running in production about the same time. So it's been a little bit for us, so that's good. And hopefully you can learn from some of my mistakes. We're up to 4 different teams working on Ratpack. So many times we've seen teams work on Ratpack. It's one small team that started to bring it in. We were already out to 4 separate teams kind of collaborating and sharing. So organizing your app. In general, these are kind of my experiences, and your experiences may vary, but this works for us in production, so take it with a grain of salt, but it works. All routing shouldn't live in Ratpack.Groovy. Even with microservices, it's going to just get too long and too hard to deal with. And then all your application logic and business logic shouldn't live inside a handler. You need to break that up as well, because once again, even once you pare it down a little bit, it gets too big. And then, in general, related things should be grouped somehow. So how to actually go about that? In Ratpack.Groovy, one of the ways we like to do it is separate related routes, such as everything under /locations, into its own chain. And so you can use your own handler chain and do it. That's mostly readable, right? Okay. So you can see we have this prefix of hubs or locations. So everything that's /hub or /locations will delegate into this chain. And then we're adding the location endpoints is a chain. So to do an actual chain, what you end up doing is you implement the action chain, and then by having this groovy.chain, you end up with this the same DSL that's in the handlers block, but you've bound it underneath the prefix of like /locations. In this case, it's /hubs. And you can see I did a little bit of just really simple rendering, but this allows us to keep everything about hubs isolated, all those routes at one place. And if we want to move this functionality because we want to potentially version the API or something like that, so we can actually have a prefix that has a version in it and then do another chain with a different version. If you want to use the version in the URL, you could also use a lot of other options, and that's probably a 2-hour conference talk, just versioning APIs, so we'll avoid that. Is there any questions so far about using chains this way? Okay. So there's a new feature actually coming in Ratpack 1.3, which should be out as an RC next week, where you're actually going to be able to include other Groovy script files in Ratpack.Groovy. And that works kind of, you can just add this include right at the bottom, and you include an entire another Ratpack. Basically, it's the same as Ratpack.Groovy, except it's you are including this in the other. So this is something coming in 1.3. It's going to be, I think, really exciting, but there are some major differences between the chain method. So first of all, it allows for bindings. So with the chain method, we're only like emulating that handlers block in Ratpack. So that's only talking about what handlers are operating on things. You're not able to compose your bindings. And in this case, you're actually going to be able to add your bindings together. So all your bindings will get, the order in which they're included will merge it together. In the case of the chain, we are just basically at one point in the handlers block, we're saying delegate everything to this chain. What we're doing with the include method is we're actually going to merge the two merge everything together. So what that means is everything is going to be from the root context that you're, like any of your path bindings or stuff in this new one. So if you look, we have to add path users. So even though like before in chain, we would say everything /users and then go into this chain, in this new include way, we're always going to start at the root of the URI, basically. But the order of the order in which you do the include statements versus the handler block actually will matter now in Ratpack 1.3. And I have a little example project out there, and what ends up happening is if you do the include and then you do handlers and you do an all in your handlers, the include statement ends up getting overridden because the all in the handlers takes precedent because of the way it gets merged in. So then you'll never get, you have to be careful to make sure you're not having paths override each other. So right now, if you're doing simple kind of just routes and handling, I think chain is a much more approachable way to look at things because it is like very delineated where you've added the chain to the thing. But if you are trying to also merge in all of your bindings and other things that are going on in Ratpack.Groovy and try to break that up into separate areas, that's something that I think the include method will work really well with. So what actually goes into a handler? In my opinion, I like to keep the parsing in handlers. I like to do lots of async calls to the business logic layer, and I like to do the calls to actually render the error cases and the completed logic. So that makes for a relatively thin handler, though. So almost all your business logic is going to have to live elsewhere, and that's just the way. I mean, it's kind of like you did Grails controllers thin, and you had a fat service layer. It's very much analogous. Which brings us to a Ratpack service. So a Ratpack service is a top-level concept in Ratpack, but it doesn't need to be used. The only reason you need to use a service is if you need to be notified of the starting or stopping of Ratpack. So a really good example is Cassandra. So we use Cassandra extensively, and whenever the application starts, we want to actually connect to Cassandra and do prepare all of our statements, because we want to prepare all our statements up front and then actually stop the application if things don't work right. So as a service implementation, if you have preconditions, you can actually fail the onStart method, which is what will get called whenever the application starts up. And so if you want to fail the application so it never boots, this is a really good place to do it. And we always do zero downtime deployments, so we're always running the old servers, and then we spin up a bunch of the new servers. So we actually want our new servers to never come online if the preconditions aren't met. And as you start adding different libraries, that's one way you're going to do this. Stopping is also the other thing that is notified on, and that's important if you want to make sure you shut down your connections cleanly, do any kind of cleanup work you have to do. Now, what happens right now is anything that's added to the registry that is of the type, like extends the type service or implements service, will be pulled out and then basically iterated through in serially. As of Ratpack 1.2, it'll iterate through serially and just call on start. And it calls it in last in, first out order of the order in which they come out of the registry, and then it reverses that order for on stop. Now that actually becomes really confusing because what ends up happening is it's all dependent on your whatever your registry implementation is. And so, for example, the juice-backed registry, which is one of the default ones used, by default orders things based on if it uses annotations, if it uses modules, and then if it's just put into the registry directly as 3 separate groups. So if you're trying to do ordering within those, it always matters what groups you put them in. So that's a huge problem if you want to make sure, if you're using kind of, I have some things that use app provide and some things that are just module binds, and what ends up happening is they all kind of get out of order. So coming in Ratpack 1.3, I totally didn't plan to like keep selling 1.3. It's just that it's solving a lot of our current production problems, so that's good. Coming in Ratpack 1.3 is a new annotation as well as this service dependencies interface, which is going to allow, you can use the annotation to simply declare this service depends on another, and then you can also use the service dependencies, which is far more robust if you, in particular, if you're combining 2 Ratpack libraries that don't know about each other, but in your app you want one to come before the other. You can just use this kind of, I didn't put it in there, but you can put, you basically say this service is going to depend on services of this type. And it's an interface that you can basically modify and control completely on your own, opposed to having to make sure the @depends on annotation is put everywhere. And is there any questions about services? Because services tend to be one of the areas that not everyone realizes that Ratpack has, and they're slightly different than the way Grails works, because really all services is doing is participating in the startup and shutdown, and that's the main focus of what a service does in Ratpack. There can be questions. There's not that many people. Yeah.
I suppose could that have been implemented using post-construct and pre-destroy annotations instead of using some other mechanism?
So, if you sort of, the reason we didn't do that is because it's actually going to, instead of starting things in serial order now, it's actually going to try to spin up everything in parallel, and then it uses its own dependency thing basically to make sure it can start everything in order, and it allows us to combine things later without the annotations, because we have a lot of people that don't like the annotations as well. The pre-construct, post-construct stuff also is very Spring.
It's actually Spring Java 7.
Yeah. That's the constructor, right?
Well, they will be called after the instance has been created by the dependency injection mechanism.
Right. And so Ratpack Service start, it happens slightly after injection. So you may want the injection to happen, but you actually want to do your connections to your database or whatever once Ratpack has started enough. It won't serve traffic until all of the on starts have been called. So it actually has booted and everything has been injected, and then it calls on start in order, and then it goes on to start serving traffic. So on start can basically stop you from, so if you do too much work there, that's how long you're delaying like serving traffic. So I've talked a little bit about juice, And so Juice is like the default registry back. You can also use Spring if you're going to do Spring Boot with Ratpack, and that's possible. But most of the time, we just end up using Juice. And so what we'll do is we'll create these abstract modules, and it's just a Juice module, and then we'll group. You'll see we have a service, a library, and endpoints. And the endpoints is the chain that we talked about before. So in our Ratpack.Groovy, we're just binding this one hub module in the binding section, and then we are able to, in our handlers block, pull in the hub endpoint controller, like the hub endpoint chain, and put that at /hubs. And then we know we've also bound all of the services and libraries necessary. The shard lib you see right there is just a pogo. So it's just a standard Groovy object, and because it's doing a lot of business logic, but it's not participating in startup or shutdown, so we didn't need to make it a service. And what it's doing is mostly async calls out to, all of those go out to actually another Ratpack service in this case. So a little bit of inception there. So a little more about services. We tend to want to make all of our services have a common interface. So we want them all to either return all Ratpack promises or all some other kind of async thing. So one option is RX Java, and there's some tight integration with RX Java and Ratpack that you can use if you want. But this is the service layer. We always want everything to be returning some asynchronous methods because we want to make sure that any blocking work always happens off the main execution thread. And if everything is returned asynchronously, it's very easy to chain things together in our handlers and just do the then and then keep chaining everything together as necessary. And it works. That tends to work really well for us, and that's kind of one of the boundaries is we don't want to have to wrap everything in blocking calls inside of our handlers. We want the services to take care of that. So whenever we want to share a set of functionality across our different Ratpack projects, they're just jars. There's nothing inherently special. There's not extra metadata or anything like that. Everything is just simple. So we tend to use bin tray for all of our open source things, and a hosted artifactory inside for making sure all that works. The interesting thing is we always try to use the lowest version of Ratpack possible. Now, the reason for that is Ratpack so far doesn't do breaking changes with minor releases. So if we make our thing work with Ratpack 1.0, we know if we upgrade all of our libraries all of our applications at different times to 1.2 or 1.3 or 1.1, all of those can use the 1.0 because that's like the bare minimum. Now the case where this is going to actually change for us is we really want the 1.3 service depends on stuff. So we're going to rev the version up to 1.3 and then just all of our applications are going to need to upgrade to that because that's just something that's really going to solve some of our problems, and we want to use that. But most of the time, unless you're using a very new feature of Ratpack, you'd be fine writing all your libraries in Ratpack 1.0 and just using everything else, and everything tends to play together fine. So far, there hasn't been any major breaking changes that would prevent you from doing that. And the same thing goes for Groovy versions or Java 8. Kind of have to make sure you're using the minimum one in your library to not drag everything else up. And I have the tendency to just upgrade it to the latest version of everything. So this is like a hard thing for me to actually remember. Oh yeah, there's a reason that's on 1.0. So the other thing is you always want to separate service interfaces into different artifacts. And what I mean by that is I talked a little bit about having RX service interfaces and also Ratpack promise interfaces. So we tend to have different groups within our company want to use RX sometimes for everything, and some want to just use like the vanilla Ratpack promises for everything. So what we do is we have the base library, which does everything in Ratpack promises, and then that will be an artifact that gets deployed. And then we have the RX version of this interface that maybe has a few more fancy methods. One example is with Cassandra. We have an execute a list of statements where we'll execute 10 at a time, and that will actually come back as an observable of rows instead of a result set, which is, in Cassandra, you're going to get a result set back, and we actually transform that into an observable of rows that you can use really easily. But if you're not using an RX, we didn't want to drag the RX dependency in from there. The other thing is you can use something called the handler decorator for common routes. So our example of this is something we call the HTTP module, and that's something we use at SmartThings, and it basically provides a set of known things we want all of our microservices to have, and a build info, just some metadata about the build itself, and that is always exposed as a route, and then we have we always expose the health check. And so we also have some custom rendering of the health check we want to do. So this module will add all those things, but by using the handler decorator, actually is going to add, because we do it before the rest in this list, we add in these routes that need to come. We want these to always win, so we make sure they're always in the beginning. And in particular, because we end up adding auth later, we want to make sure the health check is not authenticated, and neither is the build info, because they're not secret things. But this is a way to allow a juice module to basically participate in modifying your handlers by anything that basically implements handler decorator and is bound into the registry will be executed, and that modifies your handlers. Does that one make sense to people? Okay, because I find that one tricky. So monitoring Ratpack. Right now we have two key ways that we actually monitor Ratpack. And we use the health check that's inspired by Dropwizard Metrics health check, but it is focused on Ratpack, and then we use Dropwizard Metrics. So the health check itself, you just have to basically, these are the two things you need to implement, and the main difference between our health check and the health check of Dropwizard Metrics is that all of ours return a promise. So we expect them to be done asynchronously so that we're not blocking a thread trying to return the handler. And this is just a really great mechanism for checking different data stores or for doing known dependency checks. One of the keys to remember, though, is health checks are done actively. So that means for every request you do to the health check endpoint, it's going to make a request to the check method on for everything that's in the registry that is of the health check type. And that can be somewhat problematic, so you may actually want to make sure your health check is actually just reporting like a known status. So if you have, if you're using some sort of connection pool or something, you may actually just want to check the number of connections in the connection pool or something like that instead of actively checking a real query against the database. Or it's up to you, because the active check, of course, gives you a more up-to-date answer. But if your health check if you start having your health check called by every dependent service, and you have a large dependency graph, that can actually get really fat, kind of spiral out of control really quickly. So the next one we use is the Dropwizard Metrics module, and that used to be called Codahail Metrics and was called Metrics for a while, and Yammer Metrics. They just keep changing the name, it's fine. So by default, when you turn it on, it's going to actually time all the requests that come in, and provide the normal timers for all the requests. There's a new timer made for every different request by default, which means if you have path IDs or something like that that change in your URLs, you're going to generate a new timer for every unique value, which can be really dangerous. And there's also a lot of available recorders already built in to the module. So the example config that we used for one of ours is, what we're doing is we turned on JMX and we turned on JVM metrics, because if you're going to consume something over JMX for these metrics, you might as well have your JVM metrics. Just always seems like good practice. And we make these request metric groups. The request metric groups basically allow us to do a regex. So if you look at like the hub shard, we'll have hubs and then like basically a UUID and then /shard. And so every request that happens to that was generating a new metric timer. And so we actually took down our production server because it would run for about 2 days and basically fill up its memory because it generated so many timers. And for the life of me, I was like, what are we leaking? I'm like, I know we're leaking something. So one of the most important lines is actually right here at the bottom where we say other, and it just is a regex that catches everything. So everything that you don't expect. So if you have anyone doing like pen testing or something like that, one of our services tends to get a lot of really random like people trying to PHP injection attacks, and they try all these PHP URLs. I don't know why, but we just had a ton of those fill up the metrics. So we of course want to just catch everything like that under this other bucket. And so I don't really care how fast I respond to like index.php or admin.php, are you CGI bin? So it doesn't really matter to me how fast that goes. So right now, so far we've talked about a lot of things that are built in to Ratpack, and there's quite a bit there, but there's going to be a lot of libraries and stuff that you need to use that are simply not, don't work with Ratpack yet. And they don't work in the sense that there's nothing inherently hard to work with, but if you have asynchronous libraries or you have synchronous libraries, there's a little bit of wrapper you want to do to make it work easily with Ratpack. So if we have these async non-blocking libraries, if they return any of these three things, it's actually really easy to adapt them into the Ratpack's model. So Listenable Future is from Guava, and then Completable Future is the Java 8 future, but we also have something called completion stage, and that's what is actually implemented. So some things actually just implement that directly instead of Completable Future. So all you have to do is basically, we know we get listenable features back from this Java Cassandra driver, and that's been a lot of my examples because that was one of the more complex integrations we did. As long as we do execute async, we know we get a result set future back, which happens to implement listenable future. So then all we have to do is say .accept, do the promise of, and then accept it. And what's going to happen is any errors that are emitted, or because listenable future has an on error, and it has on complete calls, so that will just get wired directly into the Ratpack execution model in that case. Now, unfortunately, not everyone does things the way you may like, so here's a much more complicated way to adapt a library. This is a Redis library called Lettuce, and the problem that I had with this particular implementation is that the result set future would always return, sorry, not the result set, their completion would always complete, their async handler would always complete, and then have a status of failed or success. And what I actually want is, I wanted to modify that so that it would actually throw an error so that you can do in Ratpack promises you have the on error case or the .then. So I actually wanted the on error case to fire if it was a failed Redis operation, because that's just the semantics that works for us. And so what you'll see is we do the handler async, and where all of this is inside of the promise.of. So this promise.of is basically giving us something that we can do the d.success, and we're just saying, yep, everything worked true, because this is just going to be a Boolean of whether or not this particular operation, which is a Cassandra set operation, worked or not. There was no other information we wanted to return. But in the case of setting, there's also the case where the value isn't okay that comes back, and that's when we'll actually throw an error right here. And there's the case where somehow the value that came in and didn't have a failure or anything, if the value that came in is null, we actually get a failure command from the lettuce implementation, and that's why you'll see in this case we have a new runtime exception that we're also passing failure into. That allows us to see a fuller stack of what actually went wrong. So from this, you can kind of see you're using the D. So however you're going to adapt your asynchronous, if it's listeners, if it has its own listener kind of system instead of Guava Listenable Future, you basically just inside the on success call success, and on failure you call your failure, and you can do a little bit of logic if, like in this example, the success isn't actually always success. Now, when you're adapting these asynchronous ones, a lot of them are using Nettie now. And that's really great because Ratpack uses Nettie under the covers, and that means we can actually share the event loop group, so that, because you don't want more than one of those running, one is enough for multiple libraries all working together in Nettie. So what you can do is you have this execution.current that will get you the current execution thread in Ratpack, and then you can get the controller and get the event loop group, and that basically gives you something out of Nettie that you can pass into other Nettie configs. So in the case of the Cassandra library, we have this little DSL they have to basically return the event loop group that we want to use, and they'll use that inside their setup. Now, what's interesting is when you start sharing components of Nettie between libraries and Ratpack, you have to be somewhat careful, because the Cassandra Java driver really likes to shut down the event loop group if we shut down the session of Cassandra. It's going to try to clean up after itself. So that's what this on cluster close actually does. We actually don't want to shut down the event loop group, because that's the same one that's running Ratpack and actually the thing helping to run the shutdown sequence. So what will happen is, as you start adapting these different libraries, you need to make sure they're not trying to stop or start or modify the Nettie group that you're using in Ratpack. So that's one of the kind of biggest areas that will not make any sense whatsoever, because it will present itself as the app just stopping or just hanging or never doing anything. And it won't have errors or anything, because what will have happened is somehow the event loop group has been modified, or something inside of Nettie has been modified enough that it just simply doesn't execute anymore. And it just, I may have spent many hours not realizing that needed to be a no-op. So that's the basics of adapting asynchronous libraries and some of these Nettie libraries to Ratpack. Is there any general questions? All right. So synchronous libraries are actually way easier to adapt because we have this blocking implementation. So you do a blocking get, and then you're going to do some work inside of that. Oh, yeah. Oh, thanks. You're going to do some work inside of that, and what happens is this A promise returns immediately, and then the thread will follow the normal Ratpack execution semantics. So it'll be executed when you expect. And at that point, you can do the .then or on error and things like that. And that will get mapped. Basically, on error will happen if an exception is thrown, and .then will happen as long as something returns. So this is while it's very easy to do, what you don't want to do is, what gets tricky is if you have an asynchronous library, it looks really convenient to say, I'll just use the blocking library because it's way easier to deal with. And what ends up happening is it kind of works except for all the error cases, and it's not as performant. So you really want to focus on making sure you use the more advanced async methods if you have an async library. All right, so this is just my quick summary of things that I found useful, or teams that I've worked with have found useful that not everyone has realized. By the default Gradle setup, you want to actually run both run or run shadow. And the reason you want to do that is when you do Gradle run, it's going to start it in development mode in Ratpack, and that means everything inside of the injection that happens in Juice is actually inside of a Ratpack thread. So if you're doing things like trying to get the event loop group or things like that during injection, that's trying to get a Ratpack managed thread. And what will happen is when you go to run it as a fat jar for real, or you do the Gradle run shadow, you'll see that it says unmanaged thread exception. You're trying to do stuff outside of the right context. So it's really quick to boot and just do Gradle run shadow, and that gives you a quick sanity check to make sure you didn't do anything outside the managed threads. And I don't know if everyone knows about it yet, but I really like it, so I'm going to keep talking about it. The Gradle-T run and the Gradle-T check is the continuous mode for Gradle, and that works really well with Ratpack, and it will auto-reload and everything like that. So I do Gradle-T.check a lot while I'm writing tests. So every time I write a bunch of tests, and I'm using IntelliJ, so as soon as I switch back over to my terminal, it is saved and has already kicked off the build. And I see all of the things I screwed up, including code narc rules and everything, and that's why I'm running check. Everything's so fast. And then Gradle-T is just a continuous auto-reloading for Ratpack. The other thing you're going to want to do is actually cache promises, not just the value. So when you're doing caches, you actually, most of this is comments, you actually want to create this promise.value of the actual thing you want cached and put the whole promise in the cache, because then you're only making that promise once. Well, once to put in the cache, and then every time you retrieve it, every cache hit, you're returning a promise, so your interface is still the same everywhere. Everything's still a promise, but it's cached and you're not doing new object allocations constantly. The other thing to be careful of is you'll notice that the promise OAuth token.cache is called. Now that's something that basically when you do promises in Ratpack, if you call a promise .then twice, it'll actually execute the promise twice unless you call cache first. So you want to only execute it once, call cache, and then do a then, and then what's happening after this is we're also returning the promise. So we have two things that are going to happen at once. As soon as it returns, it's going to cache. It's going to call this and cache it in our near cache that hits up above it, and then also returns the initial call. And it's a little bit of performance squeeze you can get out of it, but it's kind of nice not to do those extra object allocations. And then we have RX Ratpack. If you're using RX Ratpack, what you have to make sure is you need to call RX Ratpack initialize. And every once in a while, because that is what basically makes RX Java use the execution model of Ratpack. And if you don't call this before you start doing RX Java operations, it sets a default thread executor, and it basically will start throwing errors and not really participate correctly. And the other thing is if you do this in a test and if you have this happening in multiple places, it's very easy to accidentally call RX Ratpack initialize twice, and then it just kind of throws an error and starts screwing up silently behind the scenes. I believe we're at 40 minutes because timing is on my laptop. So thank you. Are there any questions? Well, I will post all the slides on my Twitter as soon as I get some internet, and there's my Twitter. If you need me, feel free to ask questions. I'll be up here for a few minutes until after. Oh, yeah.
Hi. What's the best approach from a developer with skills in Greach and Tomcat to start using Ratpack?
So, in my personal opinion, the best way to make the switch is, are you using Tomcat for Java 3 kind of stuff, or just Tomcat in general? Okay, so if you're just doing servlets and Tomcat in general, if you're kind of nervous about making the big leap all the way to Ratpack, I would actually do some fat jar deployments of Grails 3 or something like that first to get used to running a fat jar. I actually find running a fat jar really easy. And then as far as digging in, there is a book coming out for Ratpack relatively soon, written by Dan Woods. And so that'll have a lot of good examples. The Ratpack community Slack channel. I personally like to get into every project by writing basically the same small user REST API. So I end up writing the same thing in every kind of new framework I work in, and I write this really small REST API. I back it with usually Cassandra because that's just the data store I use professionally now. So and then I just kind of keep iterating on that. But if you get stuck at any point, the Slack channel or Twitter has lots of help for Ratpack right now. The Slack channel has been really responsive lately and really good, not thanks to me, but thanks to other people. I'm not the best. I'm better at responding on Twitter. I'm not the best at responding on Slack, so just kind of dive in. It's not that bad. There's also a workshop that we published at Devox, and I believe the workshop was done here last year for getting started at Ratpack, and all those workshops are kind of there's a Java one that was at Devox, and Greach last year had the Groovy version. And you can go through all of those and just kind of self-run it. It's got all the solutions checked in, and so you can do the tag, and it's got all the exercises. You just kind of make the test pass, and that'd be a really good way to do it. I can tweet a link to that as well after this. Okay. Oh.
Quick question. So the RX Ratpack integration, and I'm asking about this because I actually have to talk about this later, and I want to make sure I get this right. When you call initialize, and you're saying that it hooks into that hooks into the Ratpack managed threads, and you need to do that in order to make sure that you're not using third-party. Does it? From my understanding, it creates in RxJava what's called a scheduler.
Yep.
It's a custom scheduler that allows it to make use of Nettie. Is that right?
Yeah, so it's a custom scheduler, and then it makes sure that in Ratpack things execute. There's a guaranteed, it's guaranteed to be deterministic, even though it's asynchronous.
Right.
So if you have an exception that always runs in a particular one, all of these are executed in serial. Every execution segment is serial, and it just makes sure it participates in that. Because if you don't use that, it will execute in its own thread pool whenever it wants, and you lose the Ratpack deterministic guarantee.
Perfect. I'm going to repeat that again in a couple hours.